Welcome to Brain Vision.
Hi everyone, so what we have is dough that has a hydration heat equal to 15 kilojoules per kilogram. We're given that we have 2 kilograms of flour and 1 kilogram of water that's at temperature equal to 15 degrees C. What we're asked to do is find the temperature to which that liquid water must be cooled before mixing so the hydration heat can be absorbed. So we are assuming things are occurring at steady state, so conditions will not be changing with time. So what we're going to do now is look at the properties that are given to us and also those that we have to look up in the table. So we know the specific heat of flour, CPF, is going to be 1.76 kilojoules per kilogram degrees Celsius. We also know that the CP of water is equal to 4.18 kilojoules per kilogram degrees Celsius. And we also know that the heat of hydration for the dough, so we're just going to call that 8HH, is equal to 15 kilojoules per kilogram. Now, recall that we actually have a total of 3 kilograms of dough because we have 2 kilograms of flour that's mixed with 1 kilogram of water. So if we have 3 kilograms of dough, that means we have a total hydration heat equal to 45 kilojoules. So our total heat is going to be 45 kilojoules. And that simply comes from saying that we have 3 kilograms times 15 kilojoules per kilogram. And next what we're going to do is we're going to go ahead and define our system. So we're going to define the cooling section of water as our system. And we're going to write down our energy balance. And we can say that the energy coming in minus the energy leaving is equal to the total change in energy of the system. However, we are operating at steady state conditions, so therefore this will be equal to 0, and we can say that E dot in is equal to E dot out. Now if we break the E dot in and E dot out into its constituents, we can see that E dot in is going to be equal to M dot times H1, which is going to be equal to that heat plus M dot H2. We can go ahead and just solve for Q and say that Q out, which is equal to our Q water, that's going to be equal to M dot H2, H1 minus H2. Now using the definition that H1 is equal to CP times T, we can say that the Q dot W is equal to M dot CP T1 minus T2. Now, what we can do is we can assume that all the water that is absorbed by the water is given out by the dough. So we can say that Q dot dough is equal to M CP T1 or T2 minus T1. Remember that we're looking for T1, so let's go ahead and solve for T1, and we see that T1 is equal to T2 minus Q all over MCP. And this is mass of the water and CP of the water. So we can see that with the T2 equal to 15 degrees C minus our Q, which recall is 45 kilojoules. 45 kilojoules all divided by the mass, which is 1 kg, times our CP of 4.18 kilojoules per kilogram degrees Celsius. We can get a total final temperature equal to 4.2 degrees Celsius. So 4.2 degrees Celsius is the temperature that the water should be chilled to before mixing in with the flour to absorb the entire heat of hydration.